Hello and welcome to our second video in this series of lessons about circles. In this video we will talk about the perpendicular from the center of a circle to the chord. The theorem statement says the line from the center of a circle to the midpoint of any chord is perpendicular to that chord. What does that mean? It means that the line that goes from the center directly, this red line, if you can see it, that goes from the center of the circle to the midpoint of the chord, of any chord drawn in this circle, for example this chord AB. So if this line goes exactly to the middle of this chord AB, so the result will be that this line will be a perpendicular line on that chord. How we can prove this statement? First, let's take a look at the given in this statement. What is the given in this statement? The given is that the circle of the center M, this is the circle of the center M, and we have AB as a chord for this circle. This is the chord AB. C is a midpoint of AB, so this point C states the midpoint of the chord AB. Therefore we will have AC equals to CB, so this line AC will exactly be equal to CB because this line divided into two equal parts. What we will do to prove this theorem, we will join MA and MB. So we will join them with a line, with two lines, MA and MB. Then the proof. We have two triangles as you can see here. So we have the triangle MAC and the other triangle which is MBC. So we have two triangles. If we can prove these two triangles are identical, are equal, are congruent, therefore we will be able to prove that this line is perpendicular on AB. Let's see how we can do that. First step, how we can prove these two lines are congruent. Let's take a look at AC equals CB, right? We say that AC will equal to CB. This is a given. This is a given in the theorem itself. We say that AC is equal to CB, right? The second point will be MA equals to MB. Why? Why MA equals to MB? Because both of them are radius. Both of them, they are radii. So this is a radius. MA will be equal to any other radius in this circle. So the other radius we have here, it's MB. So these two radii are equal. So this is the second point. The third point, that MC is a common line. Let's see, MC is a common line between these two triangles, right? So what do we have here? We have AC equals to CB, MA equals to MB, and MC is a common line between the two triangles. So therefore these two triangles are identical, they are equal, they are congruent. Because they are congruent, we will say that as a result, for these 3 points, we prove that the triangle MAC is congruent to the triangle MBC, side, side, side. Because we proved them by sides. We proved they are congruent by sides. We reach that these two triangles are congruent, right? Side, side, side. So this is how far we reached. Let's move on. as a result, for their congruency, what we will find? We will find that the measurement of the angle MCA, where is the angle MCA? This is MCA. So the measurement of this angle will exactly be equal to the measurement of this angle, because these two triangles are equal. So the measurement of the angle MCA will be exactly equal to the measurement of the angle MCB. They should be equal because these two triangles are congruent, right? And we know that the measurement of the angle MCA plus the measurement of the angle MCB, so these two angles, this one and this one, they add up to 180 because they lie on a straight line, so they form a straight angle. And as we know, the measurement of any straight angle should be 180, right? So the add up of these two angles together, MCA and MCB, should equal 180 because they are on a straight angle. And we know that these two angles are equal, right? And they both equal 180. So how much one of them should equal? We should divide 180 by 2 to give them the exact same measurement, right? So they should be 90. So the measurement of the angle MCA will equal 90. So MCA will equal 90 and MCB will equal 90. So they are both equal, and they are equal to 90. So what do we have here? We have proved that because this angle is 90, which is MCA, and the angle of MCB is also 90, therefore this line MC is a perpendicular line on AB, and we proved that theorem. And now let's move on to the exercise part. In exercise 2 in this lesson, we will have an exercise that says AB is a chord for the circle M, C is a midpoint of the chord AB, MC equals 3 cm, the radius MA equals 5 cm. Find the length of the chord AB. Please write down your answers in the comments below, and we will find together if you got them correct in the next video. See you.